Okay. So electrostatic, which portion you are in, Vibha?
What?
Which portion in electrostatics?
Electric charges and fields.
I'm not getting your voice audible, dear. Please be in the audibility range of camera and speaker. Yeah, tell me.
So electric charges and fields.
Electric charges and field. What about you, Vasudev?
So they're in Gauss law.
And Gauss's law. Okay, fine.
So is it Gauss's law or Gauss law? I've always been confused about that.
Gauss has got 3S in it.
Yeah, so
Gauss is the
GAU.
name.
Okay, so you say Gauss's law, right?
Yeah, like we say Newton's law. We don't say Newton law.
Yeah, I know, but there's already this S in the end, so that kind of makes it weird to say Gauss's.
Gauss's theorem.
Sure.
Okay. Okay. So the Gauss law, what does it state, is known to you, but I'll begin from scratch. I'll take two charges. They are separated from each other by certain distance. And before of letting anything related to the charge known to you, will wish to know how you decode the term electrostatic. What do you mean by the term electrostatic? What it entails, what it embodies when it comes to studying about electrostatic, what all will it entail? Yes, Vasudev.
Study of charges at rest.
Okay, firstly, what is charge? I don't know. Secondly, rest is a phenomena which is relative.
Okay, relative to each other, they're at rest. I mean, the charges that are being studied.
We'll come to it. What about charges? What do you mean by charges? What are charges?
So, the charges, charge is a property of matter. It's an inherent property of matter. And it's always conserved. I mean, there's a positive and negative side of it. Opposites attract, likes repel.
For the quantization of charge, I'm just asking for what is your understanding? How do you decipher this word charge? As you said, rightly so, it's an integral part. What we can do, as we know, mass being integral part, so is charge. We can categorize or compartmentalize the elements.
Yes.
They are exhibiting a property. For example, I take in general as a classroom, suppose n number of students are wearing specs and the rest are not. So we can compartmentalize this class into two groups. We can keep one box for the number of students with spec and the other bereft of it. Accordingly can be marked plus minus. So it's not about what they are coming with their head being marked, but with what property exhibition they are, which lead to marking them as plus and minus, and it is universal. You can swap it. Okay, you can swap it. You can, if the society so approves, you can go ahead with, okay, this will be marked minus and that'll be marked plus. It's all about what the approval is on. It's nothing to be related to the head mark or the epithet on electron with a negative or with positron with a positive. Nothing of the kind.
Is completely arbitrary.
It's totally arbitrary, and not only arbitrary, it's based on property. It's subject to property exhibited by them. Whatever property being exhibited, that particular lot which you have marked as plus or minus, it is into exhibiting a particular property, and the other lot is into exhibiting on contrary to it. So you are marking it on contrary. One is plus, the other is minus. That's it. We are categorizing. As you said, relative is what we have to take into consideration. So relative I'm taking into consideration, but then I ask you a question, which is what? Let us say I have a disk, I have rotated that disk about its axis. Our disk, it has got charge, uniformly distributed on the disk. And what I do, I rotate it. I rotate it in a particular direction. So with respect to me, disk is in motion, right?
Yes, sir.
What would you say about this study being taken under current epithet or electrostatic epithet, and why?
So if
whatever
if
effect
from
what
the-
we are to relate to electrostatic effect of charge. You said effect of charge, right? So I'll be studying about effect of charge over here, and they will be named. Let's say electric field, potential. We'll be naming them later. What I'm into asking is, what will you say about the reading of electrostatic field or electrostatic potential? We will associate electrostatic with it, or we are to coin some other term here.
So if yes, I mean, if you're analyzing this motion from the frame of reference of the rotating disk, then I'd say we can make do with electrostatic interpretation. Although if you're solving it from an external frame in which the disk appears to be rotating, I think we won't be able to use electrostatics.
I'm referring my frame.
Okay, then I don't think electrostatics would really work because the charges are moving. They also create magnetic fields in your reference frame.
So you'll be taking it through the current process, right?
Yes.
Okay, Vibha, what is your take?
So,
What is your take? What say you? So here I would like to add firstly, Vasudev, that there is no relevance to magnetism. Magnetism is not a theory in isolation. Magnetism is nothing but a relativistic equivalent of electrostatics. Why they are not separated from each other? It is subject to frame, a frame at rest. Let us say you are viewing a charge which is also at rest. Then you will associate only electric field with it. The same charge being viewed by you, you being now an elevator moving, you associate movement with charge, and then we'll study for magnetism. So magnetism and electric, they are related to each other. Magnetism and electric, they are related to each other. That's the reason we say it is electromagnetic. It is not an individual identity. Magnetism is, I repeat, relativistic equivalent of electric field. And we can prove this in relative theory. If you have a line charge and you find electric field due to line charge from a frame with respect to which line charge is at rest, and then what you do, you move, but the movement will be good. You move with a velocity equivalent to that of light. Then what is to happen? Of course, you know about time dilation and length contraction. So lambda will change. You will calculate now what is B field produced or what is E field produced. When I say E field, you'll be changing lambda value. Lambda got changed as you are moving in a frame which is moving comparable to speed of light. So lambda will change. Again, you are into calculating the electric field. You are completely alien to there can be anything else, or you are not coined the term as yet. So when you calculate electric field, this time you get electric field, which we study as a different identity. Why? Because we don't write electric for it. We rather do write magnetic for it. When you find the value of electric field, you'll get a term mu naught 4 pi. And mu naught 4 pi along with its flank is nothing but magnetic equation. We study it then in the magnetic form. But what exactly it is a relative equivalent or relativistic equivalent of electric field. So I will not be able to buy the ideation that you are in. What I would say rather, anything you want to tweak there?
So, but you said it's a relativistic equivalent of electricity. So, but then why do we observe magnetism even when charges are moving at comparably, I mean, normal speeds? Like, I mean, if you have a current flowing in the wire, the electrons are moving at drift
That is what we have. See, first we are calculating it. When we calculate it, then we get it in terms of C. We are taking V in terms of C.
Okay.
Okay. So you don't get the equation which you in general read. In that equation, when you will say that V is very small, okay, then you will get what we read as magnetic field.
Okay.
Got it? When you are looking for the actual equation, you are referring to the actual equation vis-a-vis a frame which is moving with a speed comparable to that of light. Okay. And there you don't have any similarity. But when you reduce that equation to a speed lower means the ones which we are in general frequenting. When you reduce it to that speed, then you get it an exact or ditto of what we have for magnetic field. Got it?
Yes, sir.
So that's a process. It doesn't mean that we are studying it for speed of light. Got it?
Yes, sir.
Okay. So this will be studied, the question being unanswered as yet. Anyone is to try? This will be certainly studied under the heading electrostatics. Why will it be studied under the heading electrostatic? There's a reason for it. Electrostatic, whatever be the situation of charges, if the field is not changing with time, mind you, you're positioning not on motion of charges. You're positioning based on field.
So
You're
you're
not positioning
saying
based
with
on motion of charges. I repeat, you're positioning based on field. If the field is not changing with time, over here electric field is not changing with time, look at the axial point, it will remain. And as it remains, what we have to say, we'll be studying this situation under the heading electrostatics. Fine?
So when it comes to electrostatics, the disk spinning or not spinning is really inconsequential.
Completely inconsequential. It is subject to field. Field should not change with time. So the time field is not changing. That's the reason I said it is positioned on field, not positioning on state of motion of charges. Okay?
Yes.
I'm not positioning on state of motion of charges. First is this, just to begin with. Then we have, as you know, the mundane beginning of electrostatics is with Coulomb's law, right? What is state known to you? Firstly, it is not about force, it is about magnitude of forces. Please be very careful about it. Coulomb didn't speak about force per se. He spoke about magnitude of force. And magnitude of force means what to us? Mod of force on 1 due to 2, you say, or force on 2 due to 1. What he said about force? He said about force being in direct proportionality with product of charges and inversely proportional to square of distance between them, right, dear?
Yes, sir.
We remove the sign of proportionality, we write K, Q1, Q2 by R square. I'll write it down for you because there's more than what meets the eye over here with this equation. He said F, the mod, is directly proportional to, now you will write it as mod of Q1, Q2. I'll let you know why I'm marking it with mod. Mod of Q1, Q2 and is inversely proportional to the square of distance between them. Okay?
Yes, sir.
If we are to club them, we'll get it as F is equal to K, remove the sign of proportionality also. I am taking it in one go. I'm clubbing at the same time, removing the sign of proportionality by a constant of proportion, that being K. So F12 mod or 21 mod is equal to K mod of Q1, Q2 by R square, where R is the separation between the charges Q1, Q2. Nature I am not aware of. I'm obscure of the nature for now. Okay, I'm not obfuscating, I'm obscure of the nature, I'm not aware of the nature, which one is what. Goes without saying, if both are positive, then there is no need to introduce negative or positive before of the mod symbol. If one is negative, the other positive, then when we have to remove the mod symbol, we need to keep a precursor or the pretext, right? That is known to you. I'll come to it later. For now, that is not material, as I'm referring to magnitude of force. So magnitude of force, K is what I'll shift my focus to. What is this K? K is the constant I told. What is the value of K when it comes to CGS unit? 1, and it is dimensionless. What is the value of K when it comes to CGS unit? 1, and it is dimensionless, wherever we have a dimension and the value is 9 × 10⁹ when it comes to SI system, or to be precise, we don't call it SI system, we call it a rationalized MKS system. We call it rationalized MKS system. If you're referring to higher end books, you'll get to know why do they call. We'll be taking it for now. The reason for it being called rationalized MKS system. You are aware of the constant being represented by 1 by 4 pi epsilon naught, correct? It's a weird representation. We have never represented a constant other than alphabet or a number, right?
Yes, sir.
But over here, the representation is 1 by 4 pi epsilon naught, kind of rational. Pi itself is irrational. So this is not a representation which I am in agreement with. I wanted it to be represented by, let's say, K, epsilon naught, 4 pi, whatever it would have been, would have done. Why is that this kind of presentation you are into negotiating for the first? Why do we have this presentation? This presentation is the reason why it is being called rationalized MKS system and not SI system. We call SI, but if we are purist, we'll call it rationalized MKS system. And the reason for it being, We introduce 4 pi over here so that we get rid of 4 pi in our incoming calculations. I repeat, we introduce 4 pi over here so as to get rid of 4 pi in our calculations incoming. As everywhere you would have got 4 pi, 4 pi, 4 pi. Got it, dear?
So, but the way I've learned it, it's that 4 pi is just a byproduct, the surface integral you take when you use the Gauss law to determine this. Yes?
When you are determined, so if you will not take there 4 pi, when you are taking Gauss's theorem, you are referring to Gauss's theorem, right?
Yes.
Why do we take 4 pi there?
You see, you get the surface integral of the sphere, surface area.
You have the solid angle 4 pi, correct?
Yes.
Solid angle is 4 pi, right?
Yes.
So that's the reason we are taking it over there.
Okay.
My question being, why are we taking it here? My question is not about Gauss's theorem. Gauss's theorem is well justified. Why do we take over there 4 pi? And we'll be referring to it. Referring to it in this class per se. That is justified. Why here? Why k is I? My question was positioned on k. Why k is presented as 1 by 4 pi epsilon naught? I didn't go to Gauss's theorem.
Yes.
Nothing about it. This is Coulomb, right?
Yes.
So we are presenting it so as to get rid of 4 pi in our calculations incoming. First is this. That is, how come it has got a dimension in CGS and it is dimensionless in SI system or rationalized MKS system? Why? So what is the justification for it being dimensionless? Values may differ. Okay. So there I'm not in odds with, in one case it is 1, in the other case 9 to 10 power 9. What I'm certainly in odds with is, why is that it is dimensionless in CGS and has got a dimension to its merit in rationalized MKS system? Yes, please.
I wasn't aware of this.
You have not heard of it?
It's the first time. It's the first time I'm hearing about. No.
CGS is dimensionless. Write it down and let us score it. In CGS system, K is 1 on value and it has got no dimension to its merit. Whereas in rationalized MKS system, you're aware of dimension, isn't it? And value being 9 to 10 power 9. The question being, why so? What can be the probable answer? And this should have been a pertinent question, by the way. Asudev, I would say, Viva, to you as well. It should have been a pertinent question. Rather, you should have thought of it well in advance. I have asked you, Asudev, when we were in class there at Mysore, that has it ever, to you, have you ever reckoned, or has ever it come across? Why is that in the fundamental unit, current gets space, not charge?
So, as far as I know, there's historical reasons for that.
Has occurred to you or not? First is this.
Yes, it has indeed. I mean, charge seems a more fundamental thing to.
Yeah, exactly. It is more fundamental than current, of course.
Yes, because current you can derive from charge and time. I mean,
Yeah, exactly. Current being lesser on the fundamental parameter than what charge is. Charge is more basic. Yet it couldn't find its space in fundamental units. Current did. Why? That is owing to the fact where from we are coming, and that being, we calculated force between two current carrying conductor. Force unit being known to us, we were only to know then the unit of current. We were not interested in how the current is getting formulated. So if you go back in history, it comes or it stems from the fact that we took two conductors in which current will follow, let's say in same or opposite direction that being not known to us. We found force between them, and when we calculate force with I1, I2 being there in the equation. I'll be coming to it. And I1, I2 we then related to the unit of force, there was no need to break I1, I2 in charge. That's why current was incorporated. And if current is incorporated, then there is no point taking charge exclusively, right?
Yes.
So it's from that fact. Though my question is unanswered, which being, why do we have unit 1 and dimension not accorded? And that comes from the fact that CGS is much older than MKS or rationalized SI system or rationalized MKS system. Much older than SI or rationalized MKS system. As I'm calling rationalized, why? Because I wanted to get it cemented that we are introducing 4 pi on purpose over here. Okay, we are introducing 4 pi on purpose over here. I'll not be repeating it after this class, only this class, rationalized MKS system. So you say rationalized MKS system or SI system, what I am to emphasize or assert on, I'm asserting on the dimension. There is no dimension like the fact that CGS is much older, fine, older than what? How is old to merit a consideration over here? Why being old will devoid it of a dimension? Very simple. When you say F is equal to mdv by dt and remove the sign of proportionality, you write F is equal to kma. Where is k? There is no k anymore. Why? Because F was Newton's baby, right, dear? He
Yes.
chose the unit of force. He chose the unit of force in such a manner so as to make k equal to 1 and dimensionless.
Yes.
It was his call, his prerogative, right? He
Yes.
stated it so. He was free to do so. Why? Because he introduced force. Similarly, when you're talking of a unit when force was not decided on its unit, then we had the liberty to choose whatever unit of force and in accordance just a force value of k. Okay, dear? You must be aware. If not, then please make yourself aware of unit of charge in CGS is stat coulomb. We relate it to statics, electrostatics. We say stat coulomb. Similarly, of volt is stat volt. Got it? So they are very exclusive. They relate only to which system? CGS system. And we had the liberty back then. Back then means the inception of CGS. To exercise our understanding on K. By our understanding, we will go easy. So we took it dimensionless and of quantum 1. Yes, any question here? Vasudev?
Sure. They said it was, it says Newton had the liberty to choose the value of k in its units.
Right.
Hypothetically, let's say he decided to give k some dimensions. How would that
Newton
work?
didn't get any dimension to K. He chose the unit of Newton as kg meter per second square.
If he were to hypothetically give k some dimensions, how would that, I mean, would it even work?
It will work. Why won't it work?
But
That depends on dimension. If suppose, let's say, suppose, I'm not aware of K, I want to get a dimension to K, right? So I'll say, or I'll define force, unit of force, as Newton by meter square.
Okay. So it depends on how you define this new quantity force.
Of course, I'll define force as Newton by meter square. Right?
So although dimensionally those dimensions don't make sense, but you can still get
dimension. Who has decided on dimension of Newton? Yeah, it was coined by Newton, right?
Yes, sir.
He could have said, right, that Newton by meter square or 1 by meter will be the unit of force. Then what?
So you could have said it, but that doesn't exactly dimensionally reflect what force represents.
You will be taking then the dimension for K. Why won't you represent, yeah? Then K will have a dimension to its merit. Simple. K will have a dimension to its merit. Yes, over here, when I say K is equal to 1 and dimensionless, how are you relating to force? insidious. Similarly, if I say that almost in the same breath, I'm saying that now it has got dimension. What did you do? You tweaked it and you have made it ambivalent, right?
Yes, sir.
So you got dimension, you didn't change dimension because that liberty was not accorded to you. You were not in liberties to change Newton. So what you did? You have to place value of K in accordance with Newton. It was set, the precedent was set. You cannot be a departure to it. When you're talking of the Newton, when you're talking of force rather, not Newton, when you're talking of force, the other I'm free, so I took K dimensionless. How can you say it is not in what are you saying? I'm not able to understand.
So, all I'm saying is, for example, let's say he defined force with dimensions of meter. Then I mean, I don't know. I have this connection in my head between dimensions and the actual quantities those things represent. Should I not have that connection? Is that what he's suggesting?
Newton, what do you understand of Newton? Is it in consonance with kg meter per second square?
Yeah, well, it is. I mean, yes.
Okay. Okay, fine. Let me say now that K has got a dimension.
Okay.
And that dimension, we want to associate dimension with K. And K is what to us? 1 by meter.
All right.
Okay.
Yes.
Now what will you associate with F?
The new updated value dimension, whatever comes.
Kg by second square, correct?
Yes, sir.
You could have associated with it. Why not?
He just feels
you associate with it. You're associating over here with force, right?
It's mathematically fine.
Where is the disconnect? Why not able to join the dots? Make me understand. What is macule in it? There's something macule in it. You are not able to see with clarity. Yeah.
When you say force has a dimension of kg meter per second square, that makes sense.
How?
The way you define it, it's like...
Yeah, exactly. You are talking of memory, dear. How does it make sense? As you've been asked to study this way, correct? Kg meter per second square, right?
Yeah, probably that has a part role to play.
Yeah, so that is, you're coming from a memory. I'm not talking of memory. I'm talking of when it was incepted. At that time, it was not known to mankind, right?
Yes, sir.
So you are now so related that you are beholden by kg meter per second square.
Yeah. Okay.
Right? Okay. So this being the case, what we say? Yes, it is so, owing to whatever reason being cited over here. Then, what about charge? As Vasudev was into professing, that charge is a quantized, right? By quantized, what we mean? We mean that it will be in the multiple of minimum available. And for now, we say minimum available is what is on an electron or what we associate with an electron. So charge will be quantized. Q is equal to NE. We always write Q is equal to NE, where N is an integer. Find here?
Yes, sir.
So if charge is quantized, how do you make sense of the equation dq by dt?
So if a large enough amounts of charge is assumed, the charge is continuous.
Now, these are the questions which are into coming, dear. Engineering college questions, they will ask you these questions, even if it's not asked in IT. If charge is quantized, which is what then you are implying from it is, if I am into implying from your statement, what I'm trying to imply is, just inference from your statement, that Q is NE, is a constant, right?
Yes, yes.
And a constant also a constant, right?
Yes, sir.
And a constant E also a constant, product will be a constant, right?
Yes, sir.
What do you understand of the symbolic representation dq by dt?
So first of all, Q as a function of time would not be continuous or differentiable. If we actually take charge to be quantized, there would be jump discontinuities there, right?
There will be a zero. It's a constant. dq by dt will be zero then.
Yes, sir. So I mean, if you actually think about charge as quantized, decubitative doesn't really make sense.
Doesn't make sense. And that's the reason why do we say that we are not differentiating charge. When we write dq by dt, it's a symbolic representation. It means a rate of flow of charge. It's not differentiation of charge. Okay, dear?
Yes, sir.
Symbols can be elusive. Well, let us get clarity on them. dq by dt doesn't mean that you're differentiating charge. It is a representation which is suggestive of a rate of flow of charge. Okay, coming back to what we were in, which is A quantized. Then let me throw charge with a speed equivalent to that of light. Will the charge change on it? Mass will change. Or mass mathematically is to be changed. We will study in relativity that actually there is no change. That is mathematical juxtaposition that we are into. We make it incommensurate with mathematics and say that mass will change, and actual mass is not to change. But for now, let's be in confinement of our understanding. Mass changes, it becomes infinity. So mass is infinite. What we will say about charge? Will charge change in accordance?
Charge is frame indefinite.
Charge will remain the same. Yes, yeah.
It'll remain the same. It doesn't depend on the frame.
Charge will remain same. Charge is not going to change. Even if we take mass to be changing, which is delusive, we will keep charge. We are not to change charge. Third, when we take charge, then it has got effect in its vicinity, in its surrounding. And that effect is akin to what you get around a magnet. Magnet has got an effect in its ambience. Charge also has got an effect in its ambience. And that effect is what we study under the heading, or that effect is what we express by the heading electric field or electric intensity, simply intensity. Whichever way you want to present it, electric field, electric intensity, or intensity. This is what we refer to, or we are trying to make the intangible tangible. So I'm able to feel the effect. Now I want to record it. I want to measure it. So to measure what devices we do have, few terms, and they being intensity, later potential. I'll come to potential later. For now, intensity. But what intensity? I'll come to it. Firstly, Coulomb's law is what it is to begin with. And remember, we begin with a caveat. Coulomb's law means what to us? It will associate to only one dimension, point charges. Okay? Coulomb's law will associate only to point charges. This is, please make it and rather junk all your doubts related to Coulomb's law by stating that it relates to only point charges. So 2 point charges separated by distance r, we have to find force on one due to the other, and we are referring to only magnitude. This is what the equation then for us. Moving now to the vector part of it, upscaling to our vector understanding. Write down two charges separated by a distance r. Are viewed from an inertial frame. S. Are viewed from an inertial frame S. Find equation for force on 1 due to 2. Find equation force 1 due to 2. That means force on Q1 due to Q2. Correct, dear?
Yes, sir.
How do we write? Taking a leaf out of your vector notebook, we'll mark it as F1 to the mod of it, magnitude of vector, multiplied with unit vector in that direction, right?
Yes, sir.
So multiplied with unit vector in that direction means R12 divided by R12 the mod of it. Agreement?
Yes, sir.
Okay. Replacing for F, We are aware of F12, nothing but this term. So K mod of Q1, Q2 by R squared, R12 divided by R12, the mod of it. We are aware of R12 mod equal to R21 mod equal to R, right dear? They're all same. This being then shaped to a more appealing one, I would say. Why I am saying this to be more appealing is because this will let you know generally mod is being not used. Please make it a point over here. Do use mod. If you don't use mod, you will be falling into a trap the moment I ask you on certain question. Okay, so over here a pre-barricade or a disclaimer. Please take mod. Don't take it bereft of it. Okay. Yes. Now what is so important about mod? Pretty obvious. Let's say Q1 is of the same nature as Q2, both being either positive or negative, right? Two charges I took, I'll show you the charges. This is 1, Q1, and this is Q2. Charges taken separated by distance r. Now tell me logically, if both are positive, and I want to calculate force on 1 due to 2. That is what I'm trying to do. Force on 1 due to 2, correct? Both are positive. Force on 1 due to 2. Let me show you the diagrammatic representation for the vectors as well. This is R1 and this is R2. Okay? This is 1 for me, this is 2 for me. So what is this vector? R21 vector, right?
Yes, sir.
Either you say 1, 2 vector or you say R21 vector. That is known to you, correct? Either AB vector or RBA vector. The over here the alphabet will get swapped when you use R. And accordingly we read. Either this is 1, 2 vector or this is position of 2 with respect to 1. Okay. That being known, let's move forward. You have taken Q1, Q2 both positive and you want to calculate force on 1 due to 2. So what will you get from there? Experimentation. In which direction? Force on 1 due to 2. In which direction you have to get? In the direction of R21 or R12? What will you say?
Sir, R12.
R12. We'll get in the direction of R12. And that's what we get from here. In the direction of R12, if both are positive. I can remove this mod. Both are positive, both are negative. What we can do, we can remove this mod and we'll get in the direction of R12 from equation as well. Now one is positive, the other negative. Then what we have to get force on 1 due to 2 in which direction?
So what is it?
One is positive, the other negative. Then we have to get in which direction from that equation?
So R21.
R21. Over here, what will I do? One is negative, the other positive. If it's given to me, then I'll have to introduce a negative sign.
Yes, sir.
Because what is inside of the modular symbol will be negative, right? One negative, the other positive. So when I remove the modular sign, I'll have to introduce a negative term over here. If I introduce a negative term over here, then R12 changes to R21. Either you say minus of R12 or you R21. They are same, correct?
Yes, sir, but quick question here. Even if you didn't use the mod, you would get pretty much the same results. So why are we using?
How will you resolve this equation? This equation. I want to keep it in Q1, Q2. I'm not introducing negative sign owing to physicality of it. I'm introducing negative sign owing to mathematics. It began with mathematics, right? Yeah.
Yes, sir.
Q1, Q2 not known to you. Then how can you say it will be this? I need to know Q1, Q2 being positive. Only then I can write in this form. You want to remove it, right? And you want to use this equation R12. That means you're suggestive of it will be in the direction R12. Right?
Yes, sir.
It will be the direction R12. There's no mathematics involved over there. This side is magnitude. This side cannot be negative. This side is magnitude you have written. And this magnitude part cannot be negative, right? So you have to
Yes,
make
yes.
it positive. You cannot say that it is kq1 q2 r square with a negative sign. No. Okay. So mod we need to carry. And when we are to remove it, then we are to accordingly place whatever nature we have got should be marked as a supplement. You will have to qualify it. Okay.
Yes.
So in any book of relevance, good book, you will find that they will carry mod till the end. They will not write it as kq1 q2 by r square. Okay. Next, what do we have? The effect. Now what I do, we replace Q1 by unit positive charge. So a point unit positive charge is called test charge. What is the test charge here? What is the test charge? Test charge is a point charge. Of course, it is a point charge. What nature? Positive nature. When we say test, it's obvious that it is there to test, will not partake in experimentation. Okay, dear? The moment I'm saying test charge, it is to test on something, it will not partake in experimentation. Okay? So test charge what? What will it test? Take Q1 of magnitude 1. Take Q1 of magnitude 1 and try to find force between Q1 and Q2. What do we get over here? Both are positive. What do we get over here? F12 is equal to what? Q2 divided by R cube.
R cube, yes.
Into R1. That is what we'll be getting. But when it is equation of force,
So,
when you are taking test charge as an identity, correct?
Okay. So you're breaking up.
Okay, repeat myself. It is force, but it is force between two charges, one of them being test charge.
Yes, sir.
So you are suggestive of test charge partake in this experimentation of yours, correct?
Mm-hmm.
Which is counterintuitive. Why is it counterintuitive?
Because we said the test charge.
What is the nomenclature? The nomenclature is test charge, and test charge will not be the experimentation. It will be the difference of experimentation. It is akin to you taking a measuring instrument. A measuring instrument will be an aid to your experimentation inferences. It will not take part in the experiment. Correct?
Yes, sir.
Exactly the same understanding about test charge. The moment you have taken test charge, though you are calculating force between, you may argue that I'm still into calculating force. Yes, you are. But to make that distinction, what we are to say? We are to say that no, we are not into calculating force anymore. We are using test charge to test on the potency of other charge. Which is the other charge over here? The other charge is Q2. So what basically we are trying to find here is the effect of Q2 at the position of test charge. Agreement?
Yes, sir.
So to make the distinction, what we say, it is no more force as it is not. What is that? It to be density, field, or electric field. Due to which charge? Due to charge Q2. At which position? At the position of test charge. Getting it?
Yes. Yes, sir.
At the position of test charge. You know how will it change, right, dear? So what will be the equation between force and intensity? What equation they will share? If I may ask, I am to find F12. What should I divide it by? Q1 or Q2? To get E12, what will you say? E is the abbreviation used for electric field, where electric field at 1 due to 2. Due to charge Q2.
Yes.
Q1 has lost its relevance, right dear? There's no Q1 to be seen anywhere. It has lived its utility. We have removed Q1 by test charge. So this is the effect of charge Q2 at the position of test charge, correct?
Yes, sir.
Yes, sir.
So if I am equating it with F12, then now what shall I divide F12 by? Q1 or Q2?
So Q1.
Of course, Q1 right here, because Q1 has lost the relevance. We have removed Q1 by 1. So F12 will be divided by Q1 to get E12. And coming to the physical manifestation of what we have mathematically shown on board, what can be the physical manifestation of it? How do we get to know? How we'll show it to be there physically to a student? That is what I'm feeling. It is intangible to me. What is the methodology used to present it on a piece of paper? How will you record it? How will you keep a record of it? How will you make the student understand? You will not ask him to be there in the situation. You have to make the person understand that, okay, there is something which I am into measuring, and that measurement has got a calibration. What is the calibration for this measurement? Measurement of what? Measurement of the effect on a piece of paper. How will I calibrate it? How will I be graduating it? I'll be graduating it with help of something which we call line of force or field lines. Write it down. Line of force or field lines. We are introducing line of forces or field lines. What are the features? A, it originates, you're well aware of it. Where will it originate? Positive charge, and terminate on negative or at infinity. Terminate on negative or at infinity. Okay.
So can we also say originates at infinity?
We may say, but you require particle for its origination. It can go up to infinite distance. There is no need for the presence of negative charge there. If it is originating, you require anywhere be it, you require presence of positive charge.
So, but then how do we explain the field produced by an isolated negative point charge?
We are to take at infinite value there being a positive presentation. Otherwise, we'll not be able to. It cannot originate at negative. It can only terminate at negative. What we are assuming over there is somewhere at infinity, you can, while going for the sheet, you can take a point charge as well. Negative point charge. We are taking it converging on negative point charge. So from where from? Where's the origin of it? When you are drawing a line, let's say you're drawing a line, you are not drawing it through your hat. There is an effect which you are feeling, right? You're into feeling an effect. That effect cannot be generated by negative. That effect is generated by positive charge. That effect you are calibrating as field line. Remove negative. Why do I say that it is not dependent on negative? Remove negative. It will still remain. Right? It will remain or not. Negative will generate. Positive has generated. You are calibrating it. That. So it's coming from infinity. At infinity, you will have to place a positive charge. Net potential, 0. There is no potential. So you are placing a positive charge over there. When it comes to me then, what are the other features which you can add to? Could you please tell me what the other feature which we can add to? Like anything about what will happen if you are going in the direction of field? Can the two field lines cross each other?
No, obviously not.
Okay, why can't they cross each other?
At that point, you'd have two force vectors.
At that point in time, you'll have two force vectors, so we add them.
So you can't do that, can you?
Why can't we do that? We have two field forces, E1, E2 at a point. We can add them.
So that would define another resultant electric field, right?
Exactly. That will be then the direction of electric field. Then why will we get two fields there?
Yeah.
Because when we are drawing electric field, we are basically drawing for, I have placed a charge over there, and then I see direction of force. For example, if I have to draw for positive Q, what will I do? I'll place a test charge over here. I'll look for the field in this direction. Okay, I'll draw. I'll place a test charge over here now, close to it, draw, and then join the dots. This is the methodology. We don't draw line willy-nilly. We have to place test charge and check for force. And accordingly, I get a straight line over here.
Yes, sir.
What I was trying to ask you is, can it be this way, this way? There's no point it can be this way. This is divorce of sense.
Yes, sir.
Why is it divorce of sense? Because how will you get these lines?
Yes, sir.
You will get the resultant line, correct?
Yes,
And
sir.
you will draw in that direction. Why will you draw these lines? From where you're getting these arcs?
Comes out
Not
of the fact that you need to place a test charge at that point to even get there.
So that is, the reason is not that you will be getting two electric field. That is incorrect. The very process is flawed over here. You cannot get a situation of the kind.
Yes, sir.
Okay. And when we draw, it is that we draw. We don't draw component of it. We draw net. That's the reason we say tangent to the lines at any point will get you direction of electric field, correct? Tangent to these lines, which line? Field line, that's the other feature of it. Tangent to these line at any point will get direction of electric field. Okay?
Yes.
Then comes the third and the most important one, I would say, and that is magnitude of electric field. What does it depend on? What is the magnitude to depend on? It depends on density of these lines. Denser the line, higher will be the quantum on magnitude front. I'm not a certain direction. It doesn't over here count for direction. It counts for magnitude. So it's all about magnitude, which I'm relating to density. And that's pretty obvious for you to check. See, if I take it at R1, there are n lines permeating. Okay, there are n lines coming out of it. Find here. If I ask you what is density of these lines at R1, what will you say? N divided by the surface area. What will be surface area? 4 pi R1 square, right?
Yes, sir.
Then I take it at a distance R2. Ask you again, what about density now? You say n remains 4 pi R2 square. I'm talking of density means line per unit area. Density on that context, not volume. Now this is what we get. So this is the density where at position 1, this is the density at position 2. Seek your help on E1. What will be E1? If I wish write E1 at this point, what will you say? E1 will be KQ by R1 square, right?
Yes, sir.
Similarly, E2 will be what to us? KQ by R2 square, correct?
Yes, sir.
And you can easily see by dividing them that E is dependent on density, right? See for yourself. Divide them. Okay. What do we get over here? R1 square, R2 square. Divide them as well. What do you get over here? R1 square, R2 square. What can we say from here? Just field. Think about the field. Field is proportional to. You can place the value of R1 and R2 here. This can be 1 by 4 pi epsilon naught, and you get to see from here that what does field depend on? It is directly proportional to density. Can we say that? E1 by E2 you check and E1 by D2 you check. Are we getting the same or not?
Yes, sir.
Are we getting the same or not, Bhima? E1 by E2, D1 by D2?
Yes.
Check it. Are we getting the same or not? E1 by E2, D1 by D2, yes or no?
Yes, sir.
Yes.
Same thing.
So we can say that E1 by E2 is equal to D1 by D2, yes or no?
Yes, sir.
Which
Yes, sir.
implies E1 is directly proportional to density, or E is directly proportional to density to make it generic, correct?
Yes.
The magnitude of electric field is directly proportional to density is what we get to see from here. Now 2 points which we will be highlighting later. You need to write it down on face value for now. First being, as we move along the field lines, in the direction of field, as we move along the field lines, along can be either way, so I'm ascertaining direction now. In the direction of field, potential decreases. Second one, field lines intersect equipotential surfaces. Field lines intersect equipotential surfaces at an angle 90 degrees. At an angle 90 degrees. Okay? These are 2 points we'll be referring to after of introducing potential. For now, few questions I do have. I would ask you to tell me where will field be higher. Compare E1 to E2 or EA to EB. Very simple question. This is the field line arrangement. I presume if I mark this as A and mark this as B, can you tell me which will be higher over here? As per the density, what will you say? Given, isn't it? EA will be higher than EB. Think of the same question. If these lines are to represent equipotential surface, only if you are known to potential.
Yes.
Think of the same question with the lines being now representative of equipotential surfaces. Then what will you say on field? EA-EB relation. If these lines are representing equipotential surface. Anyway, I'll come to that later when we have defined potential. For now, two charges kept right down. Two charges separated by distance, some distance. Two charges separated by some distance. A field line originating from Q1. A field line originating from Q1 terminates at Q2, making angles alpha and beta respectively, with the line joining charges.
Was this the problem you were referring to when we met?
Yes, dear. With the line joining charges. Relate Q1, Q2, alpha, beta. Direct questions being asked on these nowadays. This has got fancy only now. It's being produced for about 40 years. What will be, according to you, relation between Q1, Q2, alpha, beta? That is what we are to. We will be, but question on Coulomb, which I didn't get an answer from class I have been till date. I haven't got. And why I am not? Because they are not able to understand the articulation of question which I'll be in. So please be very careful about it. One is the mundane question which I am to ask first, and that being two charges kept at a distance r from each other in vacuum. Now changing medium. What will happen to force on one due to the other? Increase, decrease, remain. Am I clear with the question firstly?
Yes.
Two charges kept in air, distance intact. I'm not changing distance. Distance undetected, not altered. Charges same on magnitude, just medium being changed. The medium now being oil, let us say, or anything else which you can fathom. What happened to force on one due to the other? Will it change, remain same? If change, increase, decrease. What say you, Vasudev?
So it should decrease, but that's because I've read about dielectrics and capacitors.
Okay. Okay, it will decrease. Yeah, yes, please. Yes, Vibha.
So it will remain the same, so because it's 4, so it will remain the same.
Now, when we take mass, let's say I've taken point mass, and I ask you the same question. What happened to force on M1 due to M2? I'm going to gravitation and asking question now. Taking a leap out of your gravitation notebook. M1 and M2 separated by a certain distance. Now medium being changed. Will force on M1 due to M2 change or remain?
So, but wait, I want to change my answer. I say it will be the same, but the medium will also interact with these charges, and that might change. I mean, the force
Medium
is
interaction is a must over here because in gravitation we don't have anything of the kind gravitation polarization. Gravitation means charge has got only one nature, and accordingly we are to work. Oh, sorry, mass has got. Charge over here is of dual nature. The dual nature means polarization